Our second use for completing the square was writing a quadratic function in vertex form. And just like we could for solving quadratic equations, we can go through this process once and for all and write down a formula that will give us the coordinates of the vertex. So that's what we're going to do here. So we have f of x is ax squared plus bx plus c. And as our first move, we're going to group the two variable terms and factor out a. So we'll have f of x equals a times, and then we have x squared in the first term, and then b divided by a times x. And then the constant just hangs around. So now it's time to complete the square. We'll have x squared plus b over a x plus a constant equals x plus something squared. And we have our square set up. We've got x squared in the top left, which is x times x. And then for our two small rectangles here, we'll want to divide b over a times x evenly between them. So we'll say b over a divided by 2 is b over a times a half is b over 2a. And thus in each little rectangle we'll have b over 2a times x. b over 2a times x. Which means that each side here is b over 2a. And so our missing piece, the square in the bottom right corner, is going to be b over 2a times another b over 2a, which is going to be b squared over 2 times 2 is 4, a times a is a squared. So our missing piece is b squared over 4a squared. So b squared over 4a squared is the constant we need to add to complete the square. And we get that perfect square trinomial by taking x plus b over 2a, all squared. Okay, now let's think about how we use that in the context of writing the vertex form. So we have f of x is a times x squared plus b over a times x. And we want to add in b squared over 4a squared. But we can't change the value, so then we need to subtract that again. Minus b squared over 4a squared. And that's plus c. Okay. And then we group together our perfect square trinomial, and we rewrite that as a square. So we have f of x equals a times our square, x plus b over 2a squared. And then we still have a minus b squared over 4a squared term that we haven't dealt with yet. And then plus c is still just along for the ride. Okay, so we've done the complicated part. We've done the completing the square. Now we just need to simplify this. So we'll distribute the a, and we'll have f of x is a times x plus b over 2a minus a times b squared over 4a squared plus c. Now all we need to do is simplify this part. So we've got f of x equals a times x plus b over a squared minus, what do we have here? We have an a that's going to cancel out with one of the a's in the denominator. So we'll have b squared over 4a plus, we've got c over 1. We'd like to get a common denominator, so we'll take 1 times 4a, which means we need to take c times 4a. F of x is a times x plus b over 2a squared plus denominator 4a, numerator negative b squared plus 4ac. Okay, so that is the vertex form, right? We have x plus something squared multiplied by a plus something else, which means to figure out h and k, we need to look at this, and we need to look at this. We have x plus b over 2a, that's x minus the opposite of b over 2a. So h is the opposite of b over 2a. And then k is easier to see. K is just the opposite of b squared plus 4ac all over 4a. And that gives us the vertex formula. The coordinates of the vertex of a quadratic function, ax squared plus bx plus c, are given by h is negative b over 2a, k is negative b squared plus 4ac over 4a. Now, do you have to memorize that? I would say you should memorize the formula for the x coordinate. It's short. If you have the quadratic formula memorized, it's just the bit of the quadratic formula if you throw away the square root. In most circumstances, once you have the x coordinate of the vertex, it's just as easy to plug in that x coordinate to your function to find the y coordinate of your vertex. So if you don't memorize the formula for the y coordinate, you'll be able to find it really easily.